Right now, this obviously can happen deeper in projects, and it's a lot of time that goes into this. We've gone through a lot of iterations and improving this ourselves. But let's imagine we've got a couple of HVACs hitting our beam, so to speak. So go to beam penetration. So beam 1A penetration. And we can load it up. You could obviously create the calculators from the front view as well. So for the penetration, here's, well, this is quite similar to the one I created. I actually saved this exact calculator earlier, actually preparing for this, but you can see the penetrations. You got a number of penetrations. So as you go through, you can change the number from 3 to 2 to 5 and so forth. And it's quite easy to work with your mechanical services provider for the project to actually negotiate with them about how to deal with your penos. Now we've got multiple. So for us, say with our depth of say 450 by 750, you can do your reinforcement. So you can make them both unreinforced or reinforced. So for us, we can just see how it's working, or it is working right now based on the location of it is. Let's see what happens if we unreinforce the second penetration. It is still working, but telling us to use a fully threaded screw. So that's the penetration geometry. Some other checks. This is based on the new Eurocode 5. And then you got your load. So for us, we had a 47 kilonewtons per meter loading. And then you've got your different service classes. So that's based on an unreinforced penetration. But let's say if we were to reinforce it, we've got our ability to change your supply, choose your supplier here. So you got SPACs. I know is on the call. So with SPACs, you can say, all right, if they're our supplier, you can go through their available screw types. So that you got all the screws here available, fully threaded, partially threaded, service classes available and everything like that. And then you can choose the screw type that matches the scenario. So with that, you've got all the screws to go with that. And if you were to change your supplier, it is easy as a click of a button. So HBS, VGZ, again, quickly learn about the actual screw families of every supplier and design with what's available. So I'm going to just keep it like this for SPAC. So I'm sure everything works, but yeah. So you can easily go around, get to the right. So the Werox fully threaded, sorry. But yeah, you can see that, I guess it's been made easy. The other thing is you can design to the ETA or the draft Eurocode, and it has the smarts there to actually give you information on the pre-drilling required, because obviously that impacts the calculations, but the draft Eurocode may not impact the calcs in that instance. So that gives you that flexibility and ability. All right, so K factors and then reinforcement data. So if we go to 2 or 3, it all dynamically updates based on what's selected. So in the calculation, so this is one of the big updates we've had recently. So you can easily now see both penetrations check by check and what checks are actually being covered. So it's slightly different for the unreinforced penetration that has a tension verification. And you can see that's an additional check, the flexural verification. And then you got the actual reinforcement geometry check, not required for the second peno, is required for the first one, and the reinforcement design itself. So with that, at the high level, you can look at it, but all the calculations, again, not a black box. So it's good for us because we build confidence in our platform, and if there is ever something that doesn't look right, people see it straight away and lets us know. We've also implemented green here or red, so straight away when there's so many checks, you can tell straight away where the issue is in terms of a design. And tension verification, so this is the unreinforced penetration, flexural, shear, and again, reinforcement geometry checks. It's based on the ETAs or the design code method selected. And one of the things about designing with ETAs is sometimes that simple click of a button might get you that improved performance of that supplier. And with that, you actually, for a big project, you might save 10% on screws because you actually chose a better method. And that might save you $20,000 or something. So if you think about you trying to get big wins for your client as fast as you can, designing screws as best you can is one way of doing it.